I came to SMU because I recognized that there was a lot of good leadership in place from the engineering school and from our department. I felt like our school was very primed for a lot of growth. My research and teaching includes wireless networks, wireless protocols, the measurement of large-scale systems, and the design of embedded systems. So in other words, developing algorithms which then go on to real systems and are evaluated in the real environments. I teach a class on how to program iPhones and Android devices, and out of that class there were some really stellar students who wanted a senior design project on mobile phone development. And so we came up with this idea where they have an application, and we call it Wi-Eye. It's looking around your area and seeing what kind of Wi-Fi networks you have. And based on the information you get from looking at the app, you see that my neighbor's on this channel and this other neighbor's on this channel, so perhaps it would be best for me to be on a different channel. And so that's the functionality of the app. The app is basically just a tool that people can see and optimize their own networks to a small degree. We're doing a study on wireless performance around the world, and we're trying to understand Wi-Fi networks and cellular networks and understand what kind of propagation characteristics they have. If you have a cell tower at this location or a Wi-Fi access point at this location, if you're in the middle of those two things, what kind of signal strength should you expect to have? And all of that depends on how many buildings are in the city, how many trees that signal is going through. Those all affect the way the wireless is being received. And so you can abstract the propagation characteristics to a downtown area versus a residential area versus a rural area. And you can understand that in those different environments, you're going to have different characteristics. So the benefit long-term is that we would allow improved performance based on what we call context awareness or situational awareness, an understanding of the wireless channel you're in, and recognizing that channel as something you've seen before or others have seen before on a large scale. There's a word we tend to use a lot, it's called in situ, and it's a Latin word for in the place of. In situ measurements are measurements that are taken in the environment in which you're operating with the wireless network. In situ analysis means that when you design something, you don't just test it in an environment that doesn't make sense. You test it in the environment where it's going to be operating. We get real data from real situations, and that real data from those real situations drive protocol design, which will then be used and evaluated in the real situations in the future. And so it's a repetitive process that you're understanding something in the field as it's operating, and then you're redesigning things and evaluating them again in the field, and redesigning and reevaluating, and the process continues. And so that's a characteristic that I would hope that people recognize about our research group. From the classroom perspective, I try to give a tool that the students can take with them. There's near-term skills. So for example, somebody knows how to program an Android phone today. Every company has this need for how to leverage mobile phones and tablets in an intelligent way to improve their operations. So when my students take my classes, I would hope that they would leave with a skill set in the near term where they can immediately make an impact on the job market, and the longer term of recognizing new tools and technologies that are coming out so that they can learn those new tools and technologies through the course of their career, and recognize what is changing in technology and what should I be learning as I'm going throughout my career. And I hope that they develop both skill sets.